All right, awesome. All right, hello everyone. My name is Kevin. I'm the head of developer relations at Descope. We're a customer identity and access management platform, so we basically help you build authentication and authorization for your web apps, your mobile apps, and more recently, help you build secure auth for your MCP servers, and also auth and token management stuff for your AI agents as well. And so I'm going to be talking today about just kind of best practices that you can employ when you're building AI systems like agents, or you're building like an MCP server or something like that, as well as kind of go over some of the kind of broad enterprise landscape use cases today. So first, before I actually dive into some of the tips and tricks that you can employ when you're doing this, I'm going to go over the current state of MCP auth today. And so I'm sure, us being in San Francisco, I'm sure everyone has at least heard the term MCP yet, or like so far. But if you haven't, it's basically a universal kind of standardized approach to providing context to an LLM, like connecting your external data or something like that. And the way it works is at a very high level is you have like an MCP client, like a Claude or Cursor or something like that. And through the MCP protocol, connect to an MCP server. And this MCP server has standardized tools that you can define to do various functions and things for your agents. And so this is where that connection is facilitated to things like your internal database or any kind of remote services that you want to connect to. And just like with a typical kind of front end and back end, there is some authentication that typically has to occur between this process. And there's authorization involved, particularly when controlling what those agents can actually access within the MCP server. And so MCP generally is, it's a burgeoning protocol. It's kind of become the de facto standard for how you actually connect in that external data into an or connect it to an LLM. There mostly are use cases for like indie developers and small-time developers, but we're starting to see more and more enterprises want to expose their own internal resources or their own resources externally to other agents. And so you can see that like through public registries and stuff, roughly like 7,000 plus MCP servers, have been kind of publicized. And because developers are building these very, very quickly and they just want to get something out there that works, the vast majority of them either have no security, or even if they do have security, it's very, very basic auth, maybe like API key-based authentication. When you're talking about deploying these in an enterprise where you have, real customer data or real internal protected resources that you want to make sure that you have auditing and visibility for, most of them don't end up getting deployed. In fact, we work with a lot of enterprises that are helping and help them build MCP servers, and roughly about 13% we see is typical for an MCP server that's kind of started being developed by a developer and not put in production. And so some of the two kind of main use cases for MCP that we've seen at least are internal MCP servers for like your company's resources and kind of specifically for use cases that are using like an employee or workforce identity. So these are things like, you want to build a coding agent that has access to your internal repositories, or you want to build a sales agent that can actually connect to CRM data within your organization, like through Salesforce or HubSpot or something. And these internal MCP servers require, fine-grained access control, obviously. They require, role-based governance based on the role or permission that the user has, and this user being like an employee that maybe is invoking this agent to do something. And so how it actually kind of connects to an SSO provider, like your employee kind of Okta directory or Azure or whatever, that whole mechanism has to be built and protecting. It has to be built to protect the MCP server. The external connections that you see here to like GitHub and Salesforce and stuff like that, those require user level tokens that need to be managed somewhere as well. The other use case, which is also becoming more and more popular, is basically enterprises that want to expose their product to an external facing agent or MCP client. And so you can see this with like OpenAI's like connectors or Claude's connectors. A lot of kind of services now like Zillow and stuff like that are like building basically MCP servers to expose that information to the chatbot. Basically a lot of enterprises want to actually do this. And in order to actually deploy this MCP server and provide auth for it, you need to do things like basically support dynamic client registration, client ID metadata documents, things like that. And you need to provide auth specifically for like an external user. So this is similar to the auth that you would expect when they sign into like a website or something like that, where they will, as an external customer, go sign in with their Google account or sign in with a passkey or something like that, and delegate access to an agent or MCP client to do something on their behalf. So these are the two main kind of use cases for MCP servers that we've seen. And some of the common identity challenges that enterprises face is one, just adding OAuth 2.1. So despite the fact that OAuth is a well-defined protocol and AI is becoming better and better at actually understanding this protocol, actually managing and deploying that infrastructure, whether it's like just building an authorization server with Keycloak or something and hosting it, actually making sure that secrets are properly kept, tokens are issued and signed with private keys that are regularly refreshed, and all of this stuff, all this infrastructure still requires a lot of work to develop. And so just as an enterprise who's like doesn't have their own auth system, basically typically outsources this to a vendor like us or Auth0, WorkOS. You've probably heard of these companies before as well. Another is actually scopes and permissions. So defining the scopes for each function or each tool within your MCP server, basically defining scopes that either a user or an organization can possess, things like that, and implementing functionality for like an agent to get a minimum number of scopes and then maybe ask for more down the line and have that kind of granular permission. That is important, obviously, and something that a lot of enterprises struggle to actually implement. Another is enterprise SSO. So as I mentioned before, for internal MCP servers, a lot of the permissions that come from, to the agent that are derived from this basically user who's like an employee or something, come from the group or role they're associated with in the company. That's a very common use case. And typically when you have an agent that is, going to, make some tool call or something like that, typically it will inherit the permission from that user. And so basically allowing the user to sign in and identify themselves through something like SSO to their Okta, to their Azure is really important. Finally, visibility and control. Obviously, CISO, security administrators, want to be able to see all of the agent activity in their enterprise, be able to basically control and revoke consent for these agents doing something if needed, and see all of the different kind of prompt information and things like that. And just maintaining all this infrastructure is still a big challenge. And so here are some of these kind of some tips and tricks basically to keep in mind when you're actually building MCP servers or you're building AI agents and you want to build with this security and authorization control in mind. The first is when you're actually building an MCP server, you want to actually adhere to the MCP spec and you want to actually implement OAuth properly. This is, despite the fact that OAuth is, as I said, a pretty well-defined spec, and it has, although there are some gaps for how an agent might use it, generally speaking, the basics of OAuth are pretty well understood. It's amazing how many enterprises still actually don't implement it properly. And so if you're building an MCP server and you're exposing it either internally or externally, you want to have OAuth 2.1 with something like Pixie. as recommended by the MCP specification. And as also recommended by the MCP spec, you want to typically separate the authorization server. That's the server that's issuing the tokens, that's managing like where you define the scopes, where you define what those scopes entail from an authorization standpoint. You want to define that separately outside of the resource server, which is your MCP server. You typically, if it's an external server, want to implement something like CIMD or DCR. That's how the agents actually register with the server, how they identify themselves initially, and how they can get their own client IDs and help the organizational admins manage which agents are connected to the server. And finally, you obviously want to protect it with some kind of user-facing auth typically. There's also autonomous agents that might be out there that don't necessarily use user auth, but for most MCP server use cases, probably the ones where you pick off like a HubSpot CRM server off of Claude or something that most people are interacting with today. Typically, there's a user that's signing in, and there's a user auth experience built for that. And so actually implementing that, also mapping the permissions, the groups and the roles to whatever permissions that that are in the token, that is really important as well. So kind of in keeping with that, actually building scope-based access control into an MCP server, there are many ways that you can actually do this, but the most common and easily kind of intuitive method of doing so is to implement a scope basically for every single one of your tools. So this won't work in every case where you need very, very granular authorization. There are some other strategies as well. But generally speaking, if you have a scope for every single one of your tools, if the agent with its token possesses that scope, it can execute that tool. And so why this is important is typically like a tool call or the function itself might not be exactly the same as the backend API or whatever API that you're actually like connecting to or doing something with. And so potentially a tool might have multiple API calls. Or a tool might do some custom logic or custom business logic and then execute an API, something like that. And so you want to have a scope defined for that specific tool, and you want to define a human readable kind of description of what that is, so that when the agent actually asks for that scope and the user goes through the login process, they're aware of what the agent is asking for permission for. And so with that, if you have a tool or a scope, defined for every single tool, then providing the minimum number of scopes at the beginning is very, very important. And you can use that to make sure that your agents are never over-permissioned. And then you can have mechanisms to progressively ask for more scope. So this is something that actually in the MCP spec, that is in the MCP spec now that is actually relatively new. And there's a structured defined way that the MCP server can return it needs more scopes. The client understands that, goes to the authorization server and asks for more. And so using this process that's laid out in the MCP spec allows you to restrict access for your agents to do specific things and make sure that a user is always aware of what the agent is doing on your behalf. Another thing is token management. So we talked about tokens. Like the way that this is all kind of working behind the scenes is usually through some kind of token. Basically, the client possesses a token. That token is presented to the server to identify itself as the agent, also the user associated with that token. And there's also tokens a lot of times involved in the MCP server itself. What for? Well, if the MCP server needs to actually go out to another API in the actual function itself and do something, that needs a token as well. Or you can imagine an AI agent by itself on its own accord connecting to Google Calendar and scheduling a calendar invite. How is it going to do that? It needs a token for Google, right? And so there's tokens for agents connecting to MCP servers, and there's also tokens that are needed for those services that it's actually connecting to. And so one thing to keep in mind is that if you're building an MCP server and you have tools that are going out to Google Calendar, that are going out to even internal APIs, for example, those tokens typically you can leverage the MCP server to protect against the agent from having them. And so the benefit of this is that if an agent, say, has a Google Calendar, or like needs to do something with Google Calendar, and you want to make sure that this agent can't just schedule 1 million calendar invites on your behalf, how do you protect against that? Well, the MCP server effectively becomes the authorization layer. And the token that's used for Google, that's the really sensitive one that you don't want to give the agent actually access to, that is only ever retrieved in the MCP server itself, in the backend. And the agent will have its own token that gives it permission to execute that tool. But the token itself that's used for Google, that can be maintained by some other third party. That can be maintained by like Descope. We give you an easy way for you to do that, but you can basically maintain that yourself, and you only ever use that token directly between the MCP server and Google, and so you never pass those tokens to the MCP client or the agent itself. And so providing some like proprietary way of storing those tokens securely, refreshing them, maintaining them at both a user and tenant level, and doing that within an MCP server as opposed to just connecting the agent directly to Google and giving the agent that token is another way that you protect against like, maybe a rogue agent kind of going out and spamming someone's calendar, for example. Another thing is user consent management. So I talked about it a little while ago as well, but you want to make sure that when an agent actually is doing something on behalf of a user, the user is fully aware of what the agent is actually asking for permission for. And so a lot of this comes down to how you design your consent screens. If you connect to Notion's MCP server, if you connect to Atlassian's MCP server, if you connect to Linear's MCP server, there's a consent screen that typically comes up, and you can see what exactly Claude or Cursor, whatever your MCP client is, what it's asking for permission for. Some are designed better than others, but what's really important is that the user has visibility into what Claude is going to do on behalf of that user account. And so displaying all the scopes that the agent is asking for, as well as that human readable description I mentioned earlier of what that scope entails, what permissions that entails, being able to uncheck those scopes, being able for the user to step in and say, actually, I don't want this agent to be able to write to my calendar. I only want it to be able to read from my calendar. That control needs to be present for the user to be able to kind of properly manage its own kind of protection and authorization. And in keeping with this progressive scoping idea, you need to basically be able to initiate step-up consent flows to where an agent might only have access to read, and then if it needs in that moment the ability to write to some database or something like that, it can go through a standardized Auth process, ask for that permission. That permission might not have to be granted forever. It might have some time element associated with it. It might maybe only be valid until the next refresh, things like that. But implementing all of that, implementing a mechanism for the user to be able to do that is very crucial. And finally, actually the entire life cycle of an AI agent and managing that from, actually classifying and registering agents as they come to your MCP server. So if you guys, have built MCP server, if any of you have built MCP servers in the past and you've implemented something like DCR, DCR is basically a mechanism for an agent or an MCP client to go to your server and say, I want a client ID because I want to use this server I want to be able to have a user sign in and do something with it and get an access token. And so being able to actually build that functionality into your MCP server, being able to classify based on the request, okay, what kind of agent is connecting to it? Is this Claude? Is this Cursor? Is this part of my internal network with this VPN range or like IP range or something like that? Being able to determine if this should be treated as a public client or a confidential client, things like that. All of these provisioning mechanisms need to be in place. And also from an auditing standpoint, it's very important that you build audit logs for every single process of this lifecycle, including the registration, as I mentioned. Also, every time the agent gets an access token, what scopes they're actually consenting to, things like that, and how the user identities are tied to those agent identities, all of these things. And yeah, that's basically my presentation. So.